This is PrachiGupta. We are going to see the numpy uses for deep learning, all its basic fundamentals that will be helpful for us while doing the deep learning. So let's begin. Here we are importing the numpy library, and we'll see how matrix multiplication works. This is our one array that we have created using numpy, and this is the second array that we have created. A at the rate b is the main multiplication that happens on the arrays, but currently we are seeing how it works internally. So let's see. For every element in a and b, we are creating a row and column, and then we are calculating for every row and column we are doing the multiplication. So for every element of row of A will be multiplied to every element of column J of B, and this is how basically it works. Let's run it and we'll see the output. So row of A into row of B is, if row of A is 1 2 3 and row of B is 7 9 11, so it will be 1 into 7 plus 2 into 9 plus 3 into 11. Basically it's the multiplication of the element and the sum of their products. So this is how it works for all the four rows and the column combination. Now let's see how it actually is. So this is the next cell. Here we are defining again two arrays. We are doing the multiplication operation, and you will notice one thing: the matrix size array of A is 2 cross 3, for B it's 3 cross 2, and once you do the multiplication operation, the result comes in 2 cross 2. How is it? Basically it removes the dimensional inner dimensional which are matching, and it just keeps the outer dimensional in the output. So this is how the output comes and how the matrix multiplication works. The same thing is written here, that inner dimension is removed, and then only outer dimensions are used for the dot products. Moving towards matrix multiplication, why do we need it? It's the heart of the neural networks. It is very important for the deep learning, because in every layer in the neural network will perform output is equals to input at the rate weight, input multiplied by weights. And this is not an element wise multiplication, it's a specific mathematical operation that combine entire rows and entire columns. We'll see the element wise multiplication also in further cells, but right now we are seeing a specific mathematical operation. Okay, let's move forward. Here we have created let's see, we have created four random arrays, and we will print the shape of each array using dot shape function, and then we will do the multiplication of those two array x and w, and then we will add the bias to the result and we will print it. Let's see. This is the basic function of a neural network. Z is equals to wx plus b, where the size of x is this, size of w is this. So 4 cross 4 comma 3 cross 3 cross 2, what will be the output dimension? It will be 4 comma 2, because inner dimensions will be removed, and bias shape will be 2. So if you see, x at the w shapes become 4 comma 2, and once we add it, it becomes 4 comma 2, and this is the result. Let's move towards the next cell. We are doing here the bias addition in the neural network. We will see how this bias is added, and how this bias vector gets broadcasted to all the samples across the batch. Okay, let's move ahead. So we have this numpy array. What we will do is, this is a matrix array and this is a vector array. We will plot a graph to see it, how it works in a beautiful way. And then what we are doing, we are adding this vector array. This is a single vector array, and this is a 2D matrix. So we are adding this vector array to this matrix. So what happens is, we'll plot a result and we will see the output. Let me just run it. This is our matrix 1 2 3 4 5 6 7 8 9. This is our vector 10 20 30. So it will create 3 copies of this vector, and it will multiply these 3 vectors in the matrix, and what it will become, it will add this vector to this matrix, and result will become 11, 22, 33. Basically 10 is added to 1, 20 is added to 2, 30 is added to 3, 10 is added to 4, 20 is added to 5, 30 is added to 6, and similarly. And this is how we get the output. Moving forward, we have seen matrix addition with a single vector. Now we are seeing the same thing here. See, here is the matrix, here is the vector. We will print the matrix, we'll print the shape of the matrix, we'll print the vector, we will print the shape of the vector, and then we will add them, we will print the result. Let's run it. A 3 cross 3 matrix, a row vector, will add the matrix to the vector, and this is the result that we have seen earlier. The same. Now we have seen the vector addition to a matrix. Now we will see a scalar addition to a matrix. How a scalar element is added to a matrix? Basically, if we add this scalar value to this numpy array, it will broadcast it. It will add 10 to all the elements. It will broadcast 10, 10, 10, 10, 10, and it will add to all the elements. And the result will become 10, 20, 30, 40, 15. Let's, sorry, 10, it will add 10 to all this, and the result will become 11, 12, 13, 14, 15. Let me run this. This is the output. See, array plus 10, it becomes 11, 12, 13, 14. So this is the broadcasting basics. So there are three main rules. Arrays are always compared from right to left. The dimensions are compatible if they have equal or one of them is. Then only broadcasting helps. If an array has fewer dimension, it's padded with ones on the left. So that this is how it's done. And broadcasting is the magic that makes the neural network works. How? Because broadcasting allows the numpy to perform operations on different shapes. This is very essential. Adding biases to the layer of the output, normalizing the data, applying across operations across the batches. Without broadcasting, we will need lots of loop, which is not practically possible. That's why broadcasting is very important. Okay, so we have some activation functions that are defined. uh, we'll see what are those activation functions. One is the sigmoid, one is tanab, one is relu, and one is leaky relu. So every activation function has their own predefined functions. Like for sigmoid, we have 1 divided by 1 n dot xp. Xp is the exponential. Tana is a separate numpy defined function, 10h, and then relu is mp dot maximize. Basically it gives you a range from 0, like if you pass a data, so if it's less than 0 it will return you a 0, and otherwise it will return you the number. Basically it does that work. Leaky relu, it gives you a particular range, and then we will it is basically different from the relu. So let's see all these functions in a graph plotted and see how this works. I'll just run it. These are the different graphs for all the different functions. Let's move forward. So as I said, this is the function of this is the formula of sigmoid function. It basically squashes the values to 0 to 1, and it is used for binary classification. For 10h, it squashes the value from -1 to 1 range, and it is 0 centered. So for relu, it's the most popular activation functions for the hidden layers. And leaky relu allows small negative gradients. For relu, negative number were not allowed, but leaky relu, it allows a small negative gradient. So this is the main difference. So let's run this. So suppose we have created, like here we have created one array, and then we will pass this array to all the activation functions and see the output. So for sigmoid, it was used for binary classifications. It converted the array into a range of 0 to 1. 10h converted the range from -1 to 1. Relu converted the C, where it is 0 or less than 0, it converted it to 0, and others are the same. For leaky relu, we can see it is having the negative values as well. Softmax again, it divides the values, and which sums up to 1. So this is what we are doing here. We have seen different activation functions and how they work on a particular input array. We have seen their functionalities. Now activation function are just the element wise operation. uh, Basically all the element wise operations that we do, activation functions are similar to them. First let's see how this element wise function works. We have different element wise functions. We have exponential, we have absolute, we have logarithmic, we have sine, we have cosine. So suppose we have this array, and we do np dot x, so it will apply this function to this array. If we do np dot log, so it will give you the absolute value of x, add 1 to it, and it will pass to the logarithmic function. This will give you the sine value of x, and it will give you a cosine value of that x. So let's run it. See, this is our element. These are our elements, numpy array. It gives the exponential value. Logarithmic gives the logarithmic values. Sine function gives the sine values of those, and the cosine cos x gives the cosine value of this. So this is how this element wise function works. I'll just run it once again, and this is the same output. Now let's see the mathematical function. There are many mathematical functions element wise which works. Let's see how they works, similar to our normal mathematics. So suppose we have this, we'll plot this code also to see it beautifully. First let's see how it works. This is array A, this is array B. If we want to multiply them, we will multiply them and add the result to add it to the result. Now we will create a data arrays in which we will store A, B and the result both, everything. We have colors, we have labels, and we will plot a beautiful graph to show. Let's see, I'll just run this. So yeah, we have this array A, we have this array B, and we have this array A cross B. So what happens, 5 cross 1 becomes 5. For the place, first place is 6, first place is 2, first place becomes 6 cross 2, 12. Second place is 7, second place is 3, so here the second place becomes 7 cross 3, 21. Like this it works like normal multiplication. Similarly it works same for all the mathematical operations, a plus b, a into b, a minus b. It adds, it subtracts, it divides, all the same mathematical operations. Moving forward, similar basic mathematical operation. If we add any element to the array, the element gets added to the whole array. If we suppose this is the array, if we want to add 10, 10 will be added to the whole array. If we multiply 2, 2 will be multiplied to the whole array, like this. Now moving forward, arithmetic operations, let's see. So I'll just, it is basically setting up the libraries, beautiful plot settings we are doing here. For reproducibility we are setting random 42, and then we are printing the numpy version. So this is basic setup only that we do. Now array. Why numpy arrays? All the data is represented as a multi-dimensional array in deep learning. Either it's a image data, text data, batches, weights, everything is a multi-dimensional array. Images are 3D array, text are 2D arrays, batches are one or more dimensional for multiple samples, weights are 2D arrays of connecting layers. So everything here is in array. So that's why numpy array are the foundation of PyTorch, tensors, TensorFlows. Tensors are built upon. Okay, so let's see how these numpy arrays are created. Array np.array is used to create the array. Shape gives you the shape, how many elements are present in the element are present in the array gives you the shape, and dimensional give you the dimensionality of the array. Let's run this. This is simple output, the array, the shape and the dimensionality. There are 5 elements, so the shape is 5. Again, now let's see how to define a 2D array. This is very simple. We will give a nested list, and then we will print the shape and the dimension again. Similarly, for a 3D array, we give a 3 times nested list, we give the elements, and we will print the shape and the size. So this is the first element, second, and the third. Inside the first element we have the first and second, and inside that we have first and second. Like that, it's a 3 cross 3 array. It's a 3D array with the shape 3 to 2. 3 is the depth, 2 is the rows, and 2 is the column, and dimensionality is 3. Moving forward, numpy, let's see. So here again what we are doing is we are plotting the we are plotting the vector arrays. We are plotting 1D vector array in a bar graph where we are giving the color steel blue, edge color black, the font weight bold, font size 14, x labeled as index, y labeled as value, and we are enumerating on the vector and printing the values. So we are printing the 1D vector, we are printing again the 2D matrix here. Um, we are with the x label is column, y label is row. Then again we are printing the 3D matrix here with a fancy batch patch. Let's see the output. I'll just run this cell, and this is the output. This is simple 1D bar plot that we see. This is 2D plot, and this is a 3D plot. So let's move ahead. Here we are creating some special types of array. So there are some predefined functions like zeros, ones, identity matrices, which basically initiates the whole array for us. So if we do np dot zeros 3 comma 4, it will create a 3 comma 4 size of numpy array with all zero element. Ones will create all ones element of a 2 cross 3 size matrix. If you do np.i4, it will create a 4 cross 4 identity matrix. Let me run and show you the output. So 0 3 cross 3, 3 cross 4, it created 3 cross 4 all zero element array. Once 2 cross 3 created 2 cross 3 of all ones array. Identity matrices created identity matrix. Moving forward, uh, let's see, we have some more functions like np.arrange and then np.line space. It basically uses for it used for position encoding, um, and learning rate schedules and interpolation. Let me just run it. So we have 0 10 2. So it basically arrange from 0 to 10 with 2 encoding. So here it is, and from here its line space is 0 to 1 with 5. So it created 5 elements of 0 to 1 range. So basically this is how it works. Now moving towards the data type. Data type are very important in deep learning because it affects the memory usage, the speed and the precision. So it's very important we choose the correct data type. There are different data types like integer, we have float 32, float 64. If we have any particular array and if we want to check the data type of that, we can simply do array dot d type. This is what we are doing here. And if we want to know the size of that particular array, we can do array dot item size. If I'll just run it, we can see we have three arrays. We have printed the data type of all the three arrays and the size of those elements. So this is how it works. Moving forward, we will just plot a simple memory usage for deep learning. I'll just run it and I'll show you. So here what we have done, we have plotted a simple graph to explain you the understanding. So float 16 data type has 2 bytes, float 32 has 4 byte data size, and float 64 is 8 byte of data size. So the data type, the smaller the data type is, the faster the training and the less memory it will take. So this is what we have to keep in mind while using creating the variables. Now let's move ahead. Batch size. So tensor shape in the neural network. So this is very important. Understanding the shape is very crucial because in deep learning many big mistakes are made because of the shape mismatches. So the it is very important for us before moving forward with any algo or any code, we have to ensure the shape is very correct and we have to cross check the shapes of all the data that we are using. So here suppose we have one np0, we will print the shape of it. We have some another zeros, we will print the shape of it. We are just simply seeing how we can see the shapes of all different types of arrays, and we'll just print it. So see, we have batch size, we have batch size, we have batch size, and then this is the batch shape. So all the batch shapes are printed here. Let's move forward. Now we will visualize the batch images of shape and how the images are created, and then we will print the shape. So here we are printing, here we are plotting some image pages. uh, we are printing 10 images of 28 cross 28 grid. It will be a grayscale image with some random variables, and then we will print the batch shape, we will single image shape, and then we will print total pixels in the batch. Let's see. So see, the batch shape is this. A single image shape is 28 cross 28, and the total pixels in the batch are 7840. So this is how it's calculated. Now let's understand the shapes. Uh, to get the shape of any array, we will use the dot shape operation. It gives you the shape of the array, like whether it's I'll just first run it to show you. So see, we have this array 3 4 5, 3 comma 4 comma 5. Can you guess what will be the shape of this array? It will be 3 cross 4 cross 5, that is 60. For B it will be 2. For C it will be 3 cross 3, 9. This is the output. So this is how we calculate the shapes of the array. Moving forward, we'll see indexes and slicing. Indexing and slicing are both are very important concepts, and it matters for deep learning because it will be used in batch selection, feature extraction, training, and test split, test and mechanism, everything. So everywhere we have to use indexing and slicing. So for indexing, I'll just run this. This is a simple array indexing, like what we do in a array normally: 0 to 1 2 3 4 5 6 7 8 9 10. And if we print array of 0, it will print 10. If we print array of 3, it will print 40. If we print array of minus 1 is basically the last element, minus 2 is last second element. I'll just run it. So this is the same thing is printed that we discussed. Now we'll see the labeling of the indexes in a very beautiful graph format. I have run this code. Is basically draws boxes for each element. One will be steel blue and black. One will be defining the positive index. One text defining the negative index, and then we will print it. Let me show you. So this is our array 10 20 30 40. These are the positive index 0 1 2 3 4 5 6 7 8, and this red ones are the negative index minus 1 minus 2 from right to left. Now we will see the slicing. Slicing is basically selecting a particular part of the array. Here three main parameters are there: start, stop, and step, where step is the optional parameter. So for start and stop, suppose we have this array and we give array 2 colon 2 2 colon 5. So it will give you from 2 to 4, index last element minus 1, because first element is inclusive and last element is exclusive. So the start is 2, so 0 1 2 from 30 to 3 4 50, 30 to 50, it will print 30 to 50. Let's run it and see the output. Yeah, it will print 30 to 50. Similarly, colon means from starting, or if the nothing is after colon, it will be like till end. So this is how it works. Then this is the step so it will print all the elements with two step. From 10 to 20 and 20 to 30, 30 will come. From 30 to 40, 40 to 50, 50 will come. This type of two steps it will take. And for minus 1, it will be like reverse list. Now moving forward, we'll also use slicing for training and validation data split. So this is, we are doing splitting here. We have taken a data set of 100. We are doing 8%, 80% of the data set to the training data set. We have given colon 80% to the training, and then the remaining data set 80 to 100, that is 20% to the validation data set. If we'll run it, see, total samples we have 100, we have given training samples 80 and validation 20. This is how we divide our data set. Now moving forward, we have this multi-dimensional indexing. So how the indexing works in the multi-dimensional array, we can see it's 3 cross 4 matrix, and we will give it in the row column format, like 0th row and 0th column. 0th row, 0th column is first. 1 comma 2 will be first row and second column, so that will be 7. Minus 1 is last row and last column, that is 20 12. So this is how it works. I'll just run it. Let's move forward. Now let's see if we are comfortable with it or not. I'll just run it. 0 colon is 1 2 3 4, and column 0 is first column and all rows, and this is 0th column, 0 to 0th row to first row, and then first row to second column. Like that a submatrix will be prepared. So let's visualize this slicing and let's see how it looks. So this is our original matrix. One column will be this, column will be all rows and second row. uh, One column will be first row and all columns, column 2 will be all rows and second column, and this will be a submatrix. This is how slicing works. Now we are seeing the batch processing. So for batch processing, we have taken 1,000 images of 28 cross 28 pixels. We have taken 10 classes in the labels, and then we have this data sets, we have this label. We have bit size of 32 and index is 0, batch index. So starting index will be 0 comma batch size, 0 into batch size, and end index will be start plus the batch size. So we are dividing 1,000 images into batch of 32 images, and then I'll just run this. So see, we have this data and this labels. We have created a batch of 32 images of 28 cross 28 pixels. We have 32 labels also. So this is how we divide the data set in the batches. Now Boolean indexing, that is masking. So it is very useful for filtering the data. Suppose we have this array and we have to make all the positive numbers true and negative numbers false. So what we will do, we'll create a boolean mask, and then we will add that mask to array, and we will basically, this is a mask. Array is the number greater than 0 or not, and this mask we have added in our array, and we will print it. So what it will do, it will give true for all the positive numbers which are greater than 0, and negative false for less than 0. Similarly, we can use multiple conditions. If a number is greater than 0 and less than 6, then only add it to array, otherwise don't add. So it will give only you the numbers which are in the condition. Now moving ahead, we have this ReLU activation using boolean indexing. So ReLU, if you remember, ReLU was also same. It gives you 0 if the number is less than 0, otherwise the number. That's what we have seen, right? So suppose this is the array. We will print before ReLU, and we will do the ReLU function, and then we will print the ReLU output, and we'll plot the graph also to see how it looks. Let me run this. So this is the before ReLU, and this is the after ReLU. And after, you can see all the negative numbers are converted to 0. All the minus 2.50, it is same, it is 0, it's same, it's 0, same, 0, same. So this is how it works. This is the graph of the same. Moving forward to the fancy indexing, it's simply, if we have an array and we have a list of indices that we want to print. So what we will do, we will pass that indices inside the array, and it will print that particular indexes only. So I'll just run it. So we have this array, we have this indexes, and this selected will print those numbers. And this is the last cell where we are doing the vector embedding. So let's see, we have this vocab size, we have the embedding dimensionality, we have the sentence array, and then we are printing the shape of all the arrays, and we are done. So the next part we will explain in the next coming videos. Thank you.